Welcome to Filtration Matters, the regular podcast from BOFA, a world leader in portable fume and dust extraction. In this series, we'll be exploring how innovations in filtration and extraction system design are helping improve productivity across multiple industry sectors, including in laser, 3D printing, and electronics. BOFA experts will discuss how advances in extraction technology are helping optimize manufacturing processes and product quality, while at the same time contributing to a clean, healthy working environment. Today, I'm delighted to be joined by Geoff Sagar, a product manager at BOFA, who has specialist knowledge of laser processes, particularly in relation to packaging and traceability. We're all aware of use-by dates and batch numbers on everyday items, such as drinks cans, but perhaps less well known is the use of lasering in customization. We'll be delving into this topic in this podcast and looking at why fume and dust extraction is a key contributor to delivering the clear product markings needed for effective traceability. Welcome, Geoff.
Thanks, Phil. It's a pleasure to be with you again, and thanks for having me back after last time.
Geoff, let's start by understanding why lasers have come to play such an important role in creating the marks we see on so many products, whether that's on, say, drinks cans or high-value cosmetics.
Yeah, absolutely. Lasering is a non-contact marking method that offers a lot of advantages over other technologies, including superior mark quality, a permanence of the mark, and use of fewer consumables like ink, for example. Laser coding allows highly accurate and precise codes to be made at very, very high line speeds. And the latest laser technology uses often fiber lasers, and it's getting faster and faster now with codes of 125,000 or even 150,000 codes an hour becoming quite commonplace. And this has transformed multiple industry sectors in terms of productivity and overall throughput. In fast-moving consumer goods, for example, which we sometimes call FMCG, we're now seeing canning lines running at up to 150,000 cans an hour. And this increase in speed is all part of an industry push towards a just-in-time type process, with product leaving the production line faster, spending less time in warehouses, for example, and ultimately arriving at the point of consumption more promptly. So in this case, an accurate and indelible laser code on the product, whether it's a use-by date or a batch code, assists with both product tracking whilst it's in the production and distribution process, and gives consumer confidence with the information we all look at when we buy perishable goods. Outside of the FMCG sector, in contrast, we also find lasers working in heavy industry, such as in manufacturing of automotive components, for example. In this case, we're engraving detailed product traceability data on key components, and this might be a barcode, a 2D matrix code, alphanumeric characters, or even a complex manufacturer logo or brand identity of some other kind. And what I find interesting, what's interesting for me, is that all these industries have different requirements in terms of meeting the regulatory or industry standards for marking, but a lot of them have adopted laser technology because it's incredibly flexible and it's a really reliable tool for delivery of high quality markings at high speed, which will also remain durable and indelible. All of this provides productivity gains for manufacturers, and we're acutely aware here at BOFA of those needs when we pair up the performance features of our extraction systems to the requirements of the process.
So we'll talk about laser fume and dust extraction in a little more detail later, but now might be a good time to understand why manufacturers need filtration for these processes.
Yes, absolutely. This is a really simple but quite fundamental question. There are many reasons why fume extraction may be required, but I always find that they can be summarized into three key areas why laser users engage with BOFA, and these are personal comfort, policy compliance, and process improvements. And sometimes I refer to these as the three Ps. What I find really interesting is that relative importance of these different areas may shift from one industry to another, or even from one product to another. And it's important for us as a manufacturer to understand these relationships and develop our new products to maximize the fit, if you like, into those different areas. So if you look at that 3P model, the first P is often to ensure that the workplace atmosphere for people in the working area is safe from potentially harmful airborne contaminants, which might result from any given process. And the benefits of this are huge and wide-ranging because you're making a more comfortable working area for your operators. You get a more motivated workforce, less absenteeism, and generally we find they feel more valued because there's care and diligence being given to their working environment. Secondly, there may be a policy requirement, so a consideration of regulatory or legislative requirements to comply with workplace exposure levels for certain types of emissions. And this usually means installing systems which can ensure the efficient capture and safe containment of particulate. And thirdly, we have productivity. That's the third P. Often companies will invest in an extraction system for the first two reasons, for operator comfort or to comply with legislation, but then they quickly realise that keeping their expensive equipment free from dust, such as laser optics or the production line automation components, that can give them significant productivity benefits, particularly in a fast-moving consumer goods environment. Unscheduled downtime there can be extremely costly. There's also a big advantage gained by keeping a clean target area on the product itself to ensure that the mark is applied consistently and precisely to reduce product quality rejects.
So let's talk about some heavy users of laser and how extraction systems are designed to meet the three operator requirements you've just outlined.
Yeah, certainly. First, it's probably worth me just reiterating how we at BOFA tend to categorise the overall laser markets in which we operate. So for general laser processes, we divide them up into laser coding and marking, when this generally involves product moving in front of the laser. And this is like a production line item being marked or coded, like a canning line or something like that. And then we've got cutting and engraving. And in this case, we have the laser head moving over the product and the product remains stationary. Each of these requires a slightly different extraction solution, but they do share common requirements to filter fume or particulate emissions at the point of ablation, at the point of lasering, and this means the user investing in the appropriate and properly beneficial extraction technology.
Okay, so let's start with laser coding and marking. Where typically is this used and why?
Yeah, sure. Well, for FCMG type applications, canning lines, bottling lines, or other fast moving packaging, there are real benefits for the user to use a laser marker rather than an alternative marking or even labeling technology. In canning lines, for example, the laser is largely overtaking ink printing now for marking purposes because the laser provides a permanent, high quality mark, whereas ink marks can degrade if exposed to moisture, whether that's through washing as part of the process or refrigeration or any other process commonly found in this type of industry. So the laser makes a permanent mark on the surface of the substrate material, and this can be removal of material in the case of aluminium cans. Think of it as a kind of high-speed micro engraving process. Alternatively, it could be the removal of a top layer of material to expose a contrast coloured layer below. And this is sometimes used in food industry and packaging on yogurt pots and things like that. It's a bit like the art and craft thing you might have done at school, where you have a layer of black wax crayon on top of coloured paper and then use a cocktail stick to scratch off the wax artistically to reveal the colour below. Lasers now often do this on foil carton lids to selectively remove the paint or printed top layer in the form of a code or mark to reveal the contrast foil layer below. The accuracy and speed of laser coding and marking is not only critical to productivity. Some production lines are now capable of processing up to 150,000 items per hour. It's also essential for reliable traceability. And the type of laser typically determines how fast the codes can be applied and ultimately then how fast the line can run. The type of laser, for example, fiber lasers, the wavelength at which it operates and the power density it generates, all govern how quickly and accurately the mark can be applied onto the product. And in many levels, there's no room for error for these people. So BOFA extractors make sure that there are optimum marking conditions at all times.
Why is there so much focus on high speeds, and what challenges does this create for extracting laser-generated particles?
Well, the FMCG manufacturers want high speeds because it creates all sorts of productivity benefits for them, particularly in food production for perishable goods. So faster line speeds basically mean products can be processed and shipped quicker into the marketplace without the need to hold such large stock inventories in massive warehouses. It also makes manufacturers more agile and better able to respond to the demands of their customers. So increasing line speeds from, say, 120,000 to 150,000 an hour does make a huge difference to productivity and traceability, but also it does impact on the design of our extraction systems. High line speeds can cause the particle emissions from the coding point to drift and travel further from the point of extraction. So our engineers will take into account this momentum, along with the type and size of the particulate when they design or recommend a capture system, to keep the laser lenses dust-free, to ensure full capture of the fume and particulate, and therefore we ensure that we're returning clean air into the workplace. This engineering assessment is often critical to the overall efficient capture and safe containment of particles, and it requires a detailed understanding of the process characteristics and all the materials being worked, which is the case for most laser processes, to be honest. But this is where BOFA really adds value with our advice and consultancy to our OEM customers on how to maximise the efficiency of an installation overall.
Let's talk about laser engraving and its role in traceability. Where might we find a good example of this being used?
Yeah, sure. We mentioned the difference between code marking and code engraving earlier, based on whether the product's moving or stationary. And this engraving process is then often applied to put an indelible mark on larger components. For example, in the automotive industry, on larger metal components or castings, things like that. In this sort of application, we often see a robot arm, which might typically be involved to present the product to the front of the laser, and the laser then scans or moves around the product to engrave the information required for traceability. And this might be a batch number, date of production, certification marks or approvals, and quite often a company logo or branding image. So there's full traceability for future tracking of the component. In this instance, the extraction system may need to also include a nozzle design and positioning of that nozzle to guarantee full capture. The extraction flow rate will need to match and be applicable for the distance away from the target that the nozzle can be placed. And of course, we need to make sure that the filtration media itself in the extractor matches the material that's being processed. For example, some of the larger scale metal marking applications can be quite exciting and energetic with sparks and hot particulate flying around everywhere. So a BOFA spark arrestor can sometimes be employed to remove the risk presented by this kind of thing.
And of course, lasers can also be used in packaging, for example, in pharmaceuticals and cosmetics. Can you explain some of these applications?
Yes, again, lasers do indeed play a key role in customization and in communicating brand value in a lot of these consumer markets and products, whether it's by engraving logos on the products or making really neat and precise cutting and marking operations onto the packaging that they use to really reinforce the product appeal to customers. For example, in the cosmetics industry, lasers are used to create high precision logos on products, such as lipsticks, for example. And in this case, the look and feel of the product are a really essential part of the occasional premium price that they pitch to customers. So there's no room for poor marking or substandard packaging in this area. And lasers really do deliver the quality needed. And I'm very proud to say that our extraction systems enable them to do that round the clock. It's also worth noting at this point that the same rules for extraction apply to laser cutting just as much as any of the marking and engraving processes, as in understanding the effect of the laser process and temperature on the materials being worked. I'm reminded here, for example, of laser cutting of acrylic for point of sale store displays and things like that. Production of these items emit a lot of volatile organic compounds, VOCs, which need to be filtered and captured in order to maintain a clean working atmosphere. And BOFA's extractors all contain really generous carbon filters to make this really efficient.
Geoff, are there any other factors beyond emissions that should be taken into account in laser processes?
Yes, there are. We mentioned fibre lasers earlier, and the growth in fibre laser technology has also helped deliver higher speeds and precision to these processes that we've been talking about. But the laser systems themselves can sometimes also generate higher temperatures than other types of laser technology. And so BOFA has developed cooling units to help maintain operating temperatures at the laser head to ensure optimum operating temperatures can be maintained. And this keeps the laser at its peak operating speed and performance. We're very aware that how extraction is controlled can also make a significant contribution to productivity. We're all working in an increasingly data-driven and automated environment, and BOFA's IQ operating platform features a host of functions, including onboard data logs and a real-time system condition visualization, so operators can monitor whole system performance and schedule filter changes to match production plans. What I like so much about our range is the ability to match the ideal extractor to the process. Our product range for laser applications covers more than 25 model types, each of which is available with loads of custom options. The units cover a range of extraction flow rates from about 180 up to 4,000 cubic meters an hour, which is 100 to nearly 2,500 cubic feet a minute. And this enables a matched solution for just about every application.
So many thanks, Geoff, for taking us through the world of laser and explaining how extraction technology is increasingly recognised as a key enabler for productivity across multiple sectors, as well as helping maintain a healthy working environment.
Thanks, Bill.
Thanks for listening. If you want to find out more about BOFA and the benefits of filtration and fume extraction, visit bofainternational.com, where you'll find lots of sector-specific information. You can also catch up on all our podcast content by visiting bofainternational.com/podcast.